Okay, everyone, don't be shocked. You know I'm a math guy, so I have to always talk about something with math. But I know that someone in this class is going to be taking statistics at the University of Florida. You're going to be taking statistics, and one of the first things you're going to learn is about the Poisson distribution function. So that's what I'm going to talk about here, just a little bit to give you an idea what that is all about. And for those people who are not going to be taking statistics, and not even touching any math classes, oh my gosh, at least just enjoy the cartoons. So let's just get started. Poisson distribution function was created by Simeon Poisson. He was a French mathematician born in 1781. Then you could ask, what was going on at that time? Well, as a matter of fact, that was in the days of Napoleon. In fact, it turns out that Monsieur Poisson and Napoleon, they were contemporaries with one another. One of the first applications of the Poisson distribution function was making a determination about bucking horses. Apparently, during the wars in those times, in the 1800s, horses would actually buck and kill the soldiers on the field. So the Poisson distribution function was used to determine what's the probability and in how many numbers will soldiers be killed by bucking horses on the battlefields. You know, of all things. Well, anyways, let's go back to an example that we can work from today. Let's go back to the cars. You have a bunch of cars. They're moving down a road, one after the other. Each car stops at the sign and then moves on. In fact, each car moves through the stop sign one at a time. Suppose we knew that on average, 5 cars pass through that stop sign in 1 hour. So then what is the probability that twice as many cars, that would be 10 cars, would pass through that stop sign during the next hour? That's the question, and that's how we use the Poisson distribution function. Okay, let's take a look at some Poisson distribution functions. These are the curves. So I brought up a set of curves, a family of curves here. Each of the curves, different colors, the brown, the blue, the red, the green, the purple, whatever. Each of those represent the Poisson distribution according to what the average number is. And so the shapes are all the same. It's just that the shapes change according to what the average value is. And in our case, we said there was an average of 5 cars. That means we're going to go after the red graphics. Let me just bring that up separately. Okay, so here is the Poisson distribution for the problem that we were talking about. What did I say? Suppose that on average there were 5 cars passing through the stop sign. This is the curve where the average value is 5. So just take a look at the crosshairs. What that means is that 5 cars, in this case here, the probability of actually seeing 5 cars in a given hour is actually just a little bit over 17% probability. And then what do we ask? We ask the question about what's the probability of having twice as many or 10 cars. So let me just move the line over, and then you can see that the probability of that, it's just a little bit over the 2%, less than 3% for that matter. In other words, it's actually pretty low. And I would say that the the probability of actually getting the average number of cars is not very impressive either. Nonetheless, we've been able to answer our question here that for 10 cars, the probability of having 10 cars pass through at any moment based upon the Poisson distribution, it's less than 2.5%. Well, there you go. Well, okay, that wraps up my presentation on the Poisson distribution function. I just showed you how to use the Poisson distribution to estimate the probability of an event. For our example, that would be twice as many cars as average passing through a stop sign. You can use the Poisson distributions for other types of events on 3 conditions. First, you must be able to observe an event one at a time. Second, the occurrence of an event must be independent of any other occurrence. And then finally, you must be able to count the average number of events within a given time period. With that average number alone, you can estimate the likelihood of any number of events in that same time period. Well, thank you for listening. Have a great day and keep counting those cars.